Previously on Retro Hack Shack.
And here we go. Here's the computer. Right next to Programming Quickies, we have the Horizon, the complete computer. And they were originally known as Kentucky Fried Computers, with the beautiful wood grain, actual wood case here. Basically, everything is kind of slid down. The adhesive has worn off or melted or become just sticky and not actually tacky enough to hold this in place. Or maybe the CRT itself has become dislodged on the inside. Well, on today's episode, we're going to see if I can get this thing actually up and running. We got to test the power, make sure that's okay, and then we'll fire it up, see if we can get the screen to come on and look the way it's supposed to and all of that kind of stuff, and fix it up the way it should be, and we'll get this thing hopefully up and running. But if it'll run is anybody's guess, you're going to have to stick around and see. It's coming up right now on the Retro Hack Shack. So one of the first things that I always do when I'm starting up a new machine like this is I always test the power supply first and then move on to other things on the board that may be problematic. So in this case, I actually ended up taking this into the makerspace during one of our vintage nights and got some help kind of testing out some of these big caps and just to see if they were good and just to make sure that the rails were good. It's kind of fun to bring things in and let people kind of work on them or help. And so in this case, we tested the capacitors and the main lines here, and they all look like they are good and operating correctly. So what I want to do at this point is it might be hard to see, but they're right down here. The power connections for the floppy drives are here. So we got plus 12, plus 5, and ground are right here on the board. So that gives me a convenient place to test to make sure that those voltage rails at least are working. That'll let me know that at least the voltage regulators, the 12 volt and 5 volt voltage regulators on the board itself are working before we plug any cards in here and try to get this thing up and running. So let's hook up some power and break out the multimeter. Okay, there's not a lot that could go wrong except for these big caps. I don't see any caps on the board. Of course, the regulators could be bad. There's some big beefy carbon resistors up here, but there's not a whole lot on the board right now. So I feel pretty comfortable going ahead and turning it on and just seeing if we get the right voltage. So I'm going to hit the switch here. Oh, fan is on. I've got a red light on the front. I know you can't see it, but that's a good sign. So that would appear to indicate that things are working. 5 volts probably is going to the LED. 12 volts is probably going to the fan, unless that's an AC fan. It could be. But let's just go ahead and test these rails out and see what we get. The 5 volt rail is sitting at 5.01 and some change. So that's really good. Let's test out the 12 volt. Careful not to short these out. And the 12 volts sitting at 11.86, so almost 12 volts. So that is perfect in my book. And I've got one floppy drive hooked up. I didn't notice if the light came on when it spun up or not, but it's probably drawing some power. So yeah, it looks like under a little bit of load anyway, voltage rails are looking good. I think we can move on from this step to just doing a visual inspection and making sure that all of the ICs are pushed firmly into their sockets. Because as I said before, they have a tendency to pop out over time with temperature changes and things like that. So I'm going to turn this off and I'm going to push in every single IC and make sure that it's firmly seated. A little bit of corrosion on some of these, but it doesn't look too bad. They're really popping back into place here. So any one of these that was loose or had developed, a little bit of oxidation while it was loose from the socket, and these are probably not the best sockets either, but any one of these little chips that was loose could be a problem when we go to test this. So it's always a good first step anyway to get these things firmly reseated. And sometimes you have to pull them out and actually put them back in, maybe with some deoxit to clean things up. But I'm just going to push them all in first. That'll be the first thing we do. And this memory, for anyone playing along at home, is all Texas Instruments TMS 4108 memory. That's how we get to the 32K on here. And it's all looks like in really good shape. But that's a good indication. Texas memory most of the time has pretty good memory. So it's not the cheap memory, that's for sure. So it should be Should be good. And now it's time to thank the sponsor of this episode, PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. Okay, now I want to turn my attention, before we go any further with the North Star Horizon computer itself, I want to turn my attention to this Hazeltine 1500. I know I keep saying that, I just don't know. It could be Hazeltine, could be Hazeltine. I don't know. But it would be great if this was working. Obviously, the cosmetic damage has to be fixed, but I thought we'd do a quick power test of this as well. It does have a little power on light here, but it also has a power switch in the back here. So let's see if I can find that. Oh, I hear high voltage. That's good. So far, nothing on the screen, though. Let's just give it a minute and let this tube warm up. Okay, and folks, we have a cursor. It's down there behind the glass and the gasket, but there is a cursor there. So that's good news. What we can do is we can hook up a little loopback on the transmit and receive, and then start typing some characters and see if they're echoed back to the terminal. It should just come back and get written out to the screen, just like it was coming back from the computer itself. Except there's no logic here. It'll print whatever we type. And to do that, I think we need to connect pins 2 and 3 on the serial port. So let me go get a jumper and we'll hook those up. All right, so this is what I'm going to use for the loopback. It's a little overkill, but I couldn't find the right gauge wire to just plug into the pins on the socket back there. So I'm going to use my handy dandy 25 pin to 9 pin RS-232 converter here. And then I've got my jumper connected to pins 2 and 3 here. And the nice thing about doing it this way is, sometimes, I think I mentioned this before, but sometimes when you're looking stuff up online and you're looking at the pinouts diagrams, it's like, wait a second, is pin 1 here or is pin 1 there? And sometimes it gets a little confusing. So at least this way, everything's labeled and broken out correctly on this little board. So by doing it this way, I know I've got things connected the right way and I don't have to go messing around with, wait, is this the female or the male version? Blah, blah, blah. It should be all ready to go. And with the screw terminals here, these wires are nice and snug. So it should be the only two things jumpered here. The only two things making a connection should be pins 2 and 3, which should be receive and transmit, which gives us our little loopback test. Let's try it out. Okay, here we go. Ooh, I'm seeing letters. I don't know if you can see that. There's a little bit of a reflection in here. Let me get down to where maybe you can see it. There we go. It's pretty clear for me. I don't know if you're going to be able to tell. The type is small, so this must be 80 columns here, or I guess, right? But yeah, everything's working. The keys are working fine. Spacebar, return. Line feed's not going to do anything probably at this point. Either as escape. We could do caps, turn caps on. Caps is working. So yeah, this is looking really good. Wow, nice and sharp. Nice thing about these terminals, especially with the anti-glare plexiglass or plastic sheet that they would put in front of this kind of smoky sheet, is it really makes these letters really clear. I don't even have to do any adjustments to this. I mean, this looks perfect to me. The only problem is, of course, is that this gasket has come off and we have to get this back on. I definitely want to keep that. You could see it without it, but yeah, it's not going to look nearly as good without this plastic sheet here. So, okay, time to open this up and see if we can fix this. But for now, this terminal looks like it's working just fine, at least from a loopback test standpoint. So I don't even see that many screws on here to take this thing apart. It looks like there might have been some screws here at one time, or maybe for a different model. I don't know, but there's no screws here. The only ones I could find are these here, and they're really nice because they're locked in there so that they screw in, but then they don't fall out. How nice is that? This is like a technician's dream of a system to work on, at least to get it apart, is You know, you just loosen these up. They kind of drop back, but they don't fall out so that you never lose them. That's really nice. But I think that's all it is. I think it's just those 2 screws. Oh, nope. There's 2 more. I see 2 more in the back that are right here holding the top on. So it's a good thing I didn't pry up on that. There we go. And again, the screws are held in so they don't come out. So you never have to worry about losing those screws. Man, how nice. I wish they would do that on more stuff. I guess this was more professional gear here. Okay, the CRT is coming out with it. I really should discharge the CRT, but I'm just going to be careful. There is there's a connection here that I can just unplug, I think. And then this should all come out. Let's see. There we go. Look at that. So the whole CRT here, the CRT itself just comes off as a separate unit. And then you've got the rest of the terminal here with all the logic and everything. It looks like there's an expansion board. So here's what the terminal looks like. You've got the keyboard, of course. It's all one big motherboard from the front to the back, with the back part being the serial connections back there. But this is all one big board, keyboard built in and everything. So that's pretty neat. It looks like maybe there's a speaker here or something. But yeah, here's the board. Got some big old caps back here. I'm assuming that just underneath here, because I saw some big screws, it's probably the transformer. Again, it's probably a linear power supply. But the nice thing is that this was the connector here that went into the back of the tube like that. And then it just had this other connector that I unplugged. Whoops, there it is. This connector that I unplugged. Very modular design. Really nice. And it looks like there's a card slot connector for maybe some expansion or something. And I bet if we look down in here, I don't want to take this thing apart. Yeah, you're not really going to be able to see in there, but there is it's a linear power supply. All the power supply stuff is right down in there. And it looks like there's some adjustment pots. Let me see if I can get this to focus. There's some adjustment pots in there as well. So if we needed to adjust maybe some of the voltages or something, there's some pots in there for that. But overall, this thing is really clean. Not much dirt. There's a lot of glare coming in, but not much dirt. Thing's really, really clean considering that it's 42 years old. This thing is 42 years old. And somebody took really good care of it and stored it in a place with very little dust, because I don't hardly have to do any cleaning at all. This stuff that you can see back here is just from the paint, that when they painted this case, it was probably this color initially, and they painted the back black. And, some of the speckles got in there during the painting process, but of course they didn't care about that. So yeah, really cool. Okay, now here is the top of the terminal with the CRT in it, and this thing is super clean. I mean, there's a little bit of something that dripped down in there, and there's just a tiny bit of dust. I mean, it's so hard to see. I mean, the back of the CRT here, the neck, you can still see inside. Normally, when I take these apart, especially if they are color tubes or older TVs like I've worked on before, this is just completely dusty. The static electricity and everything just attracts black gunk and everything. But this thing, I mean, it's not new, but it's pretty close. I mean, it's definitely low use. I mean, even the flyback here, oh, that's a little loose. I'm gonna have to make sure that's tightened up. But yeah, even the flyback, the rubber on the flyback here, it looks like this was potted in silicone, and that is still springy and nice. So this is pretty incredible. I'm in pretty great shape. One thing that's different about this, since it's a terminal, is it actually has more electronics up here. There's a big old cap here, and more electronics just for the monochrome, essentially a TV component, which is up here, without the tuner, of course, but just the part for energizing the CRT and doing that part is up here on top. This would be the top of the case here. Now you can see over here the that screen, that plastic screen that goes in front of the tube to help cut down on some of the glare. And that is definitely fallen down, but it's not loose. I mean, I'm pulling pretty hard on it. It's still there. So I don't know what happened. Maybe this thing got like heated up in the sun or something. I was expecting to open this up and find like a bracket loose or something like this, but there's nothing loose. It's held in, the CRT is held in here, and then there's a couple more screws up top. There's no standoffs that are broken. It is a plastic housing. So I thought maybe the standoffs are broken. None of that is the case. So I think I can just take this out and put everything back together the way it's supposed to go, and maybe that will just do it. Maybe it'll just work, or at least for a while. So I'm going to work on taking the CRT out and just seeing if I can get everything to line up and just put it right back in where it's supposed to go. And as I'm taking off the high voltage anode here, it reminds me that I should tell people, if you're not used to working with CRTs especially, they have high voltage. And so if you're not used to working with high voltage, please seek some professional help, or don't attempt these types of repairs. You can get a really nasty, nasty shock from I can't remember what the mono is. I think it's on color. It's like 22,000 volts or something like that. So yeah, just be careful. Word of warning, discharge your CRTs, know what you're doing here before you attempt this, if you haven't done it before. Now I am going to have to take the yoke off the CRT. And so to do that, I'm going to, luckily there's a line right here in the yoke that lines up, pretty much in the middle of the CRT. Otherwise I might have to mark it with a marker or something to make sure that I can get it back on correctly, but I don't think that'll be an issue in this case. So I'm just going to cut through this, stuff here. It's pretty soft, but it's like, hot snot, some sort of hot snot, hot glue. It's kind of a silicone thing, but I'm going to cut through here kind of carefully and take my time and do that. And then I'm going to loosen up this clamp here on the neck, and this should slide off. All right, there we go. That is off, and now I should be able to very carefully get the CRT out of here. Let's see. There we go. And yeah, now we can see what's happened here. I don't know if someone tried to work on this before, but it looks like the gasket has shrunk, but also doubled up down here. So I'm going to try to get this off of here. It does come off, but yeah, that's what's happened. So you can see down here, it's disintegrated. This little rubber gasket has kind of disintegrated around here. And the glue, it also got kind of weak and yucky. So that's all going to have to get cleaned back up. And I'm going to have to find another gasket, or perhaps make one that will go around here. So I'm not sure how well this is going to come up on camera, but this all around here where that adhesive was and that gasket, it's almost like a silicone adhesive or something. I mean, you can kind of scratch it off a little bit, but it still leaves a really sticky residue. So I've been trying a couple of things to get it off. And what I have, I did this side here. So this is pretty clean. It's still got a few balls of silicone coming off, but this side over here I did already, and this side over here I did not. And I didn't, this is still not done yet, but just this little corner I did. And what I did was I used this, the Rossignol lighter fluid. I've been really impressed with this stuff. It doesn't smell great, but it does seem to work for a lot of sticky messes, better than orange oil and better than WD-30. So first I went over with that. That really loosened up that silicone stuff and got it down to the glass basically, so there wasn't anything sticking, but it was still kind of pilly and kind of yucky looking. Once I loosened it up with that, then I just came back in with the IPA. This is 91% isopropyl alcohol, sprayed that on, cleaned that off, and I think that is going to do the trick. It's looking a lot better up here, so I'm going to go do the rest of it and see what we come up with. And here it is. It's looking pretty good now. I just had to use a little toothbrush to get the little silicone things out of the edges there where it was kind of getting wedged in between the glass and the metal bracket. But yeah, it's looking really good now. And then, of course, I had to do the same thing with the little plastic sheet that went in between, basically just using the lighter fluid and then the IPA, a little polishing, and it came out pretty nicely. One interesting thing I did find after I got this all cleaned up is you could see this outline of where the CRT was. And I think the gasket maybe was helping to prevent some of the yellowing in the plastic over time, but now there's this phantom outline of the CRT. And now with everything cleaned up, it's time to just reassemble everything in backwards order the way I took it out. I can also slide the plastic piece in between the CRT and the front of the case. And then after getting the monitor screwed in, I could slip the yoke back onto the back of the CRT. And luckily there was a little divot there where this thing came off. So it really did make lining it up much easier. Then I could tighten up the clamp, and the only last thing to do was to take a look at this flyback transformer. And as you can see, the bolt holding on the flyback transformer has broken. And this is a fairly common occurrence with CRT TVs and monitors of this era. Now, one thing you could do is you could use a metal coat hanger and carefully bend it around the flyback transformer and kind of clamp it down that way, but it's difficult to do and it never comes out quite tight enough. So what I decided to do was drill an extra hole in this aluminum plate here, which is definitely thick enough and won't cause any problems. And then I can use some zip ties, some heavy zip ties, and really tighten this thing down so that it doesn't vibrate and move around as you're using the CRT. Now with everything reassembled, I can just put the case back on the terminal and we can test this thing out, see if it works. Okay, well, it certainly looks good with the power off, but will it work? Did I bump anything inside? Is it gonna break? Is it gonna blow up? Who knows? Let's find out. Nothing yet. Oh, there we go. It's coming into focus. It's looking good. Just takes a minute to warm up, that's all. It's like a little caret is the type of cursor, and I think you can change the type of cursor either with a command code or in the dip switch settings, but let's just see if the keyboard's working. Yeah, look at that. Looking good. Is there a reset button on here? Yeah. Oh, that doesn't actually clear. Oh, we can clear it. I love, okay, let's see if I can type again. I love the Retro Hack Shack. Woohoo! Yeah, to my eyes anyway, that is looking really good. All right, so now it's time to move on to the computer. I've got the cards installed, but before I turn it on, with the cards installed, I know the voltages are okay. I tested those before. But not with the cards in. And my concern here is that there might be a short on any of these cards between ground and the voltage rails, and that could cause a problem when I turn this thing on for sure and blow up more stuff, which I don't want to do. So what I'm going to do is just insert all the cards and then test the rails and make sure that there's no short between the rails. Now, doing a little research on the S100 bus on my phone over here, it looks like there's an 8-volt rail, a 16-volt rail, and a negative 16-volt rail. And then, of course, there's ground. And so what I want to do is I want to test between all of those and make sure that there's no shorts. Now, what I did was I pulled out one of these cards, and luckily over here, there's a nice little 1 marking over there. So I know that's pin 1 through 50. And then on the back, turning it over on the silk screen, there's a 100 over here. So again, assuming that this is 51, pin 51. In fact, yes, there's a 51 right there. So, so we've got pin 51 and pin 100 on the back there. So good. Now that I know where all the pins are, I should be able to put this card back in, and then using one of the empty buses, I know you're not going to be able to see that, but using one of the empty bus slots, I can then test those pins and make sure that there's no shorts between any of those rails. And obviously, if I didn't say it, I'm doing this, of course, with the power off before I plug it in. And then when I do plug it in, I'll use those same connections to test for the proper voltages on the slots. But I'm sure that'll probably be okay because we tested before. And at least this, the 12 volt and 5 volt stuff was working. When I power this on, I do want to test if the voltages are correct, the 8 volt, 16 volt, and negative 16 volt on the rail as well. Okay, so I'm not really seeing a dead short on the rails. You can see here's the, what is that? The negative 16. Yeah, that's the negative 16 volt there. And you can see there was this happens a lot when you're testing and there's a capacitor in the path, which there should be here. You'll see it, your meter will start, it'll beep for a second because it's going through that capacitor. And then as the capacitor, I guess, charges up as you're testing, it'll kind of go away. So that's pretty typical. So that was the negative 16. And the positive 16 is on pin 2. So that has the same sort of behavior. And then the positive 8 volts is on pin 1. And that is behaving similarly, but it's taking a lot longer to get to either charge the capacitor or something, but it is going up. So it's not a dead short. So I think that's okay. But what I'm going to do is I'm going to go ahead and just to make sure, I'm going to remove all of these cards and test it again and see if it has the same behavior and make sure that it's not one of these cards perhaps that is causing that to stay that low. I don't think it is. I think that's just the capacitor taking a while to get charged up. But anyway, I'm going to test that, remove all the cards and test it again just to make sure. Yeah. So exactly the same behavior as before. So if that's an issue, it's not an issue on the cards. I'm going to go ahead and power this up, I think, without the cards installed first, and just check those voltages on the actual slots, in the slots themselves, see what we're getting. Okay, let's see. I think pin 1 is an 8 volt rail, getting 10 volts. There's not much load, so that's probably okay. I think the next pin should be one of the 16 volt rails. It's up to 21. Again, I think that's okay. I think, is it this one that's the negative 16? Yeah, no, that's negative 22. So I think that's all for a linear power supply like this. I think that's all okay and within specs, because that voltage is going to get passed through the regulators on these cards for 12 volt and 5 volt or whatever they need. And that's within spec of these regulators, I believe. So it shouldn't be any problem at all. So let's go ahead and plug these cards back in and test it out. Okay, this will be the first power up with all the cards in. Keep your fingers crossed, no smoke. I don't want to see any of these tantalums busting a gut here. Here we go. Oh, wonderful. So we've got a light on one of the memory cards. That could be completely normal, I'm not sure. And we've got a light on a floppy drive. So, oh, and it went off. That's an even better sign. If that light had come on and stayed on, that could have been because of a faulty connection or a short somewhere on the card, but it actually came on, did something for a while, and went off. That's telling me that most likely the floppy controller card is okay, and probably the processor card is also okay, because the processor would probably be giving the instruction to say, okay, you looked long enough, stop looking at this point. Turn that motor off on the drive. So yeah, this is looking really good. Let me put the top back on. We'll hook up the terminal, see if we get anything on the screen. All right, we're ready to go. I'm a little nervous. I'm a little shaky, I've got to tell you. Got the monitor powered up for just a minute now to actually get a cursor. I'm about to turn this thing on. Will it actually work with very minimal or no fixes, really, so far? All I've had to do is push in a bunch of ICs to make sure that they're well seated in their slots and fix some cosmetic issues on the monitor. It would be a miracle, I think, if this computer actually booted up after 42 years since it came out. So at least that's according to the date on this floppy drive. So let's just turn it on, see if we get anything on the screen. May not get anything with no disk in there, but let's just see what happens. Okay, we've got power. So far, nothing on the screen. No errors, no nothing. That could be completely normal. Okay, I'm going to go ahead and try to put in a floppy disk and see if we get anything different on the screen. One thing to note about this particular computer is it took hard indexed floppies. And what that means is that the index is baked into the floppy itself. So there's little index holes that are drilled, and that's how it knows, drilled through the magnetic media, and that's how it knows where things are. Computers like the PC, for example, the IBM PC and Commodore 64 and a bunch of others, I think, did not use hard sectored, I think is what they're called, disks. They didn't use those. They used soft sectoring of the disks, which means that, it would write the sector information on the floppy drive, and you wouldn't have to have these holes to know where it was. So I had to go out and source these. I found a guy that was willing to send me some, and he also sent me a mod, which, if I have time, I'll show later, which actually converts, is able to convert soft sector into hard sector. So I built that mod, and I'll probably talk about that later, but let's just see if we can get the computer to boot off of this floppy first. And I haven't cleaned the drives yet. I probably should do that. I may have to do that, but I've got it in drive 1. Let me reboot here and see what happens. Okay, I checked the manual and verified. I've got the terminal connection in the right port, but I did have the disk in backwards. Let's turn that around. That could be the problem. All right, let's try this, see if we get anything. I definitely got some information or something happening on the floppy here with that disk in the correct position, but I'm still not getting anything on the terminal. So why is that? Okay, well, I still think this thing is actually working. Something just tells me the way that the disk drive is operating when it boots up, something is telling me that it is working. So I was using this adapter. I couldn't initially find my 25 to 25 pin RS-232 cable. And so I was using this 25 pin to 9 pin and then with a 25 pin adapter on to make it 25 to 25. But when you do that, of course, any modern computer, this would probably work fine for because they don't use as many signals, unlike a terminal like this one, which probably needs some of the additional signaling that's on the full 25 pins, which is why they had 25 pins in the first place. Later on, when you got into the late 80s, 90s, the 9-pin serial cable was more common, and things were just architected around that, it seems like. I don't think I had a 25-pin, after the 1990 or so, I don't think I had a 25-pin for anything. But anyway, this is from 1976, not 1990, so I figured there may be some missing signals. So I found a true 25-pin RS-232 cable in my bag of cables, and I've plugged that in. So let's go ahead and turn this on now and see if indeed that makes a difference. Power button. There we go, it's on. Let's see. Hey, look at that. That was it. North Star DOS 5.1 DQ. I don't know what DQ means, but look at that. It's actually working. The Kentucky Fried Computer rides again. It lives. Can I do like, I don't know. I'm not familiar with this version of DOS, so I don't know. Does it? No, it doesn't know that command. Okay, I'm going to go ahead and look up the, oh, that's awesome. I'm going to go ahead and look up some of the commands for this versions of DOS, the format of the commands, and make sure that it actually is working. Okay, well, as expected, the commands are not the same in North Star DOS as other DOS. DOS really just means disk operating system. Microsoft DOS became so popular that whenever anyone says DOS, you just assume it's Microsoft DOS, but there's a lot of other DOSes out there. This one is North Star DOS, and I finally figured out the command to list the directory on the disk was just li. So you type li, a little bit non-intuitive, and then you get a readout of what's on the disk. So you can see we have basic, FP basic, and a number of other files that I assume, and DOS, of course, and a number of other files I assume are probably for DOS to function. Also, basic is on here, but I think you have to type go basic in order to get it to run. Let's see, go basic. Okay, it's doing something. And then it comes back with this string T2, D1. I don't know what that means, but I don't think, because the cursor hasn't changed, I don't think basic is loaded. That's what I was trying to do earlier with list command, because I assumed that would work. There's There's no BASIC loaded right now, I don't think. Let's just try to print something to the screen and see. Yeah, it doesn't know. So BASIC isn't loaded, so there must be some sort of error. Maybe this is track 2, disk 1, sector 12. Yeah, I don't know. It's not working. Okay, so now this time I just did a list operation and it's giving me that same error again. So I am going to see, I did clean this drive, I thought, didn't I? Maybe not. Maybe I didn't clean this drive. Let me go ahead and put the disk cleaner in there and let that run and see if maybe we've got some bad heads or something going on here. Okay, heads are clean. Let's try this. Well, hopefully clean. Let's try this again. There we go. That looks better. Now let's try go basic and see what happens. Nope. Still doesn't like that. Can always try the second drive and see if that's any better. I think you do go basic comma 1 or comma 2. Nope. Must be comma 2. Oh, look at that. Yeah, so there's something with this first drive that it doesn't like. I'm surprised we got this thing to boot at all. But now it says that we're in BASIC. So can we do this? Run it. There we go. Kentucky Fried Computers for the masses.
Hello to Colonel Sanders and his Kentucky Fried Chicken.
Look at that. It's working fine. Is there a break? Does break work? How do we break out of the program? Ah, Control C. It works. And like with most computers of this era, there was a version of CP/M that worked. So not only did North Star have their version of DOS that ran, but you could also buy CP/M, which was probably considered even at that time a more powerful operating system than DOS. And of course, there was a lot of CP/M compatible things that you could run on these computers. I think there's a version of WordStar, for example, for word processing. That's a CP/M version, CP/M compatible program. But let's just go ahead and reboot and see if we can boot into CP/M. Here we go, 56K CP/M. Now this should look much more familiar. You can see down here we have an A prompt. And CP/M was really, I think, the first operating system to use the commands that you would expect to use with like Microsoft DOS. And there's a whole history to that, which I should probably do an episode on at some point. But, you know, CP/M kind of created this construct. So CP/M, of course, was a product of Digital Research. And there's a whole history of the battle between CP/M and Microsoft DOS. When the IBM personal computer came out in 1981, and you know it was either going to be basically CP/M version of DOS or Microsoft's version of DOS. Well, Microsoft didn't actually have a DOS, so they bought this company or this version of DOS called just called 86 DOS, not even x86 DOS, 86 DOS. They bought that from Seattle. What was that company called? Seattle Computer Products. That's what it was. Seattle Computer Products. So they bought that and then basically renamed it to MS-DOS and sold that to IBM for the first personal computer. Well, you know, 86 DOS was basically just I don't want to say it was a copy of CP/M, but it was very, very similar to CP/M, right? I don't know if it was actually stolen, but certainly the concept was stolen because it was basically the same. In fact, I'm sure if we do dir, yeah, see? It just works. It looks basically like you would expect DOS to work. Yeah, so anyway, now that we're in CP/M, everything kind of looks more familiar. If you're familiar with traditional Microsoft DOS, for example. And there is a, let's see, there's MBasic. I wonder if that will work. Let's try it. Nope. Get that same error. So there's obviously some more cleaning that has to happen here, it looks like. Okay, I've got some extra disks here, so let's just try to format one and see if get any errors when we do a format. Yep, we do. Definitely some issues going on here. It kind of works, but kind of not. It could be some alignment issues as well. that can happen with these drives over time. So perhaps I'll have to go back through and align these drives and make sure that they're working correctly. Well, there's definitely something wrong with these drives. I've noticed as it's gotten a little bit colder over the past few days, when I've come out to start this up, it makes a noise that sounds like this. And then I get nothing. There's no more prompt on the screen. My feeling is that because it kind of changed its behavior with the temperature, is that there's probably some, not only alignment that has to be done, but also some lubrication and some cleaning inside those drives. So I'm going to do that on another video. If you want to see that video, make sure that you hit the subscribe button or click the bell, which will notify you when the episode comes out and you'll be able to see it more easily. Also, hit the like button and leave comments down below if you have some ideas, about this wonderful wood grain Kentucky Fried computer that I found at eWaste. I'm really digging this, to use a term from the 70s. It really is a really cool system that came out really at the birth, from my perspective, of the personal computer revolution, right at the beginning there with Apple, the Altair, the MSI, the Commodore PET, and the TRS-80. So it happened right along the same time. Really interesting history with all of that Kentucky Fried Computer stuff. So I'm having a blast looking at this. If you want to see more, let me know in the comments below. As always, thanks to all my patrons. Stick around. In a few seconds, there will be some after episode commentary for my supporters on Patreon. So thank you very much. And with that, thanks for watching. We'll see you next time. Patrons receive ad-free and early access to content after the episode commentary, and of course, your name in the credits. If you liked that episode, here's a few more you might enjoy, and I thank you for your support.
End of line.